Okay, Unit 3, Artificial Intelligence Resolution. So, resolution is a theorem proving technique uh, invented by mathematician Jan Allen Robinson, the year of 1965. So, steps for resolution. So, conversion of fact into first order logic. That means conversion of fact into first order logic. And convert first order logic statement into CNF. Then negate the statement which needs to proof of by contradiction. Then draw resolution graph unification. So conjunctive normal form, that is called a CNF. Convert your FOIL statement into CNF. That's a second step of resolution. The CNF expansion is conjunctive normal form. A sentence represented as a conjunction of classes is said to be conjunctive normal form or CNF. Example: John like all kind of food. Apple and vegetables are food. Anything anyone eat and not killed is food. Anil eats peanuts and still alive. Harry eats everything that Anil eats. Prove by resolution that John liked peanuts. So step one, so conversation fact into first order logic. So these are the way they have to conversion using Vx, which that quantifier, universal quantifier, invert the inverted A, that's a universal quantifier. So using that they converting first order logic. So the added predicates. Step 2, conversion of first order logic into CNF. So what is CNF? CNF I already said conjugative normal form. A sentence represented as a conjugation of classes said to be conjugative normal form or CNF. So CNF we have to eliminate all implication here, and rewrite that. So inverted X, food X like John X, and food apple in so inverted A, food vegetables. So similarly inverted AX, inverted AY, that's a universal quantifier, eat X and Y. So kill X, V, Y, food. Like that conversation of first order logic into conjugative normal form. So here the third step, you know, they used the statement, negate the statement to be proved. In the statement, we will apply negation to the conclusion statement, which will write written as like John peanuts. And step four, um, John and peanuts like food and like John and X, and food peanuts eats Y and Z and killed Y and food is Z, and easy Y peanuts we killed Y eats Anil and peanuts kill Anil alive K and inverted a universal quantifier and killed K, then alive Anil. Finally, the both are equal alive Anil. Hence, it is proved. So the draw resolution graph is completed. So based on the graph, there is an explanation. The first step resolution graph like John peanuts and like John X get solved and cancelled by substitution of peanut and Rx, and we are left with food peanuts. In second step, the resolution graph food peanuts and the food is that solved, that means cancelled by substitution of peanuts. We are left with eats peanuts and killed. And third step, easy peanuts and eats anil peanuts are resolved, that means cancelled by substitution of anil and y, and we are left with killed anil. And fourth step, resolution of grab killed anil and killed k get resolved, that means cancelled again the substitution of anil k. Then we are left anil alive anil. The final step, the resolution grab, so both are get resolved. Okay. So next, ontological engineering categories and objects. So ontological, a vocabulary for the domain knowledge. Ontological engineering representing various ontology. So there are five-step methodology. So decide what to talk about and decide on vocabulary and predicates and function on constants. Encode knowledge about the domain and encode general knowledge about the domain and encode description of the specific problem instance. Post queries to the inference procedure get answers. So general ontology. So advantage of or special purpose on general ontology categories, measure, composite objects, time space change, event process, physical objects, substances, mental objects, and beliefs. The veiled ontology. Veiled ontology. See the diagram. It's familiar in every. If you search the Google, it will become only the anything that abstract object event. So another abstract objects sets number representation objects. So another event interval places physical object process. So similarly, under set categories representation objects sentences and measurements. So in the measurement they may saying times and weight. Similarly, under the physical objects they're having things and stuff. So under the things there is a animal and agents. So under that humans and stuff is solid, liquid, gas. So it's hard to build real world ontology. Say already built it for electronic circuit domain. So they're having ontology. That R gate, AND gate. This is a full order circuit. So decide what to talk about AND gate, R gate, XR gate, NOR gate. So that is the first step. And second one, decide vocabulary of predicates and function and constant. Example, the output 1 and x1 and encode general, where it is output 1 and x1. Here you see that x means XR gate and a means AND gate. So x1 means number one XR gate. The output 1 means the output get it from the XR2 output. So encode general knowledge about the domain. Example, invented a quantifier, universal quantifier connected to T1 and T2. Then signal you will be getting T1 and signal that is equal to signal 2. Then encoded description are the specific problem instances. Example type X of 1. So that's XR and post queries to the inference procedure to get answer. So the combination of input would causes on the first output C1 the sum of the bit to be off. You know the so the answer might be how it will be A X or B, that's Y that output, and some A X A and B and C like that the output you will be get it. So that's a full order someone carry output. Okay, then thank you.